Hey, we're on the last lesson in chapter 6. Imagine you're all glad to get there. Much like we've done previously, we're finishing up here with inequalities. When I say previously, in past chapters, with some ideas about inequalities. And the big thing here is that if you have a line in standard form, ax plus by equals c, can be described, the half planes that it cuts. In other words, as it cuts across it, there's an area above the line and below the line, and they can be described by these two inequalities. The line itself, ax plus by equals c, is the boundary line. And if it's included or not determines on how we represent it. The half planes, we might shade them in, but this gives us linear inequalities, and we'll see that they're actually fairly useful to work with. When we graph a linear inequality, we want to look at, first we graph the linear equation. Then we determine which side of the line contains the values that are all solutions to the inequality, and we shade that in. If it's the inequality symbol, if it's less than or equal to, determines whether we have a solid line or a dashed line. You remember when we did this with number lines, we would have our number line and we'd have our tick marks on it. And if we were going to make an inequality, we might put a circle where the line was to indicate that that's the boundary point but is not included. And then we would draw an arrow to show the direction. If it was included, we'd fill it in. It would be a solid dot. Well, what this means for us when we're graphing is if it is an inequality where it can't be equal, but it's either greater than or less than, then that's going to be a set of dashed lines. It's hard for me to do this by hand. And they're going to go off in whatever direction they go, and they could go forever depending on the situation. We put little arrows on the end to indicate that. And so this would be a case where we have, I don't know, this is ax plus by. The area we're going to shade is going to be above or below it. So if this was greater than, if this was the ax plus by is greater than c, then we're going to be shading in this area here to say it's above that boundary line. If we were drawing this and it was going to be a solid line, well, that solid line would mean we had something of the form ax plus by is greater than or equal to c. So the boundary line is part of the solution, but again, we would shade in the region that marked that off. Okay, let's move on before I obliterate everything there. We're going to go ahead and graph our first inequality, and this asks us to graph x is less than or equal to a negative 2. Less than or equal to means that our boundary line is part of the solution and will be included. Which side we shade, we're going to have to figure that out. Well, first we need to graph it. We know that x is equal to negative 2, so that's looking like a vertical line here. So here's 1, 2, so y could be 0, y could be 4, y could be anything as long as x is always a negative 2, but it's less than or equal to. So we'll go ahead and we'll make our boundary line. Put some arrows on it so we know it's there. So that's our boundary line. Now the question is, which side will we shade? And sometimes it's useful to use a little color when you're doing your shading just to help to show how to color it in. But for x is less than or negative 2, for this to be true, then it has to be to the left of the line, because it could be -5, -10. It can't be 1 or 10 or 0, because those aren't less than that. So what I'm going to do is I'm going to shade in this region. And by shading this in, I'm indicating that everything to the left of the line is a possible solution. I don't need to do the whole thing. I could have put in a number of kind of hatched lines rather than just scribbling all over. That would have worked as well. So that's the idea here when we shade in these values to get our results. Okay, on to our next problem, which is to write an inequality that describes the set of points in the shaded region. So now it's asking us to look at a graph and figure it out. Well, the first thing I can see here is this is a dashed line. So the boundary line is not included. And it appears that everything is above it, so I think I've got a greater than symbol there. And since it's a horizontal line, well, horizontal lines are the ones where, remember, if it's horizontal, then it's y equals something. So this is going to be y is greater than, well, it's kind of knocked out, but that's a -1 there. Y is greater than a -1. So we've had two examples here. In this last one, we had a vertical line. That's one of those, you remember the x equals lines? And in this case, x was greater than or equal to. And here we have the y, the horizontal line. Y is greater than a -1. Okay, let's draw another graph. And this is asking us, this is a little bit more complicated. Draw the graph of y is greater than 3x minus 3. Well, we know because it's y is greater than but not equal to, the boundary line is not included. Therefore, we're only going to draw it as a dashed line. But it's still useful in this case to do our xy table to find out where the boundary line is. Again, keeping it simple. If x is 0, y is -3. And if y is 0, then x is 1. 3 times 1 is 3. 3 minus 3 is 0. So I've got a point there at 1, 0. I get another one at 1, 2, 3. At y -3. And now I need to go in and figure out how I can draw a dashed line here. I'm not sure how good my tool is for doing this. I can do lots of ruler would be good for this. I don't have one in this app. The other alternative is I could have drawn a straight line and then gone in and erased part of it, but you'll be doing this paper and pencil, so just do the dashed line. Use your ruler to straighten it out. Don't get all weird like I did there. But here's our line. It's a boundary line is drawn because y is greater than 3x minus 3, and now I need to figure out which side to put this on. I'm not sure whether it's going to go to this left side or over to the right side. The way to do that is to test a point. It's digital. By that I mean if I test to the left and it doesn't work, then it's the other side that I shade. So I don't have to test exactly where I think it's going to go. I can just test where it's easy for me to draw it in. So let's look at 0. If 0, 0. So if y is greater than 0 minus 3, that's true. That's going to be a true statement right there. So if that's true, that would mean the other side would be false. So let's just, for instance, try x is 10, y is 0. and we would get that 0 is greater than 27, which is decidedly not true, so that's false over here. But all I needed was the true statement. And I'm going to go in and draw my hashes over here and on the left side to indicate this is going to be the shaded region. And so now I have the solution with the boundary line drawn. The t-table was used to draw the boundary line. That's all I needed it for. I'm not saying that's part of the solution, but I needed it for a boundary line. Okay, another one. Graph a negative 3x plus 5y is less than a negative 15. Again, what do I do? Dashed line or solid line? Well, the boundary line is not part of the solution, so therefore it's going to be a dashed line for the boundary line. I can still put together my table so that I can get my x and y results and draw my boundary line, my dashed boundary line. Zeros are easy. If x is 0, then 5 times what equals a negative 15? Well, that's going to be a negative 3. A negative 3 times 5 is a negative 15. If y is 0, a negative 3 times what is negative 15? Well, that's easy. That's 5. A negative 3 times 5 is 15. So I have my 2 points that I can draw the line with. I'm going to put one at 0, negative 3. 1, 2, 3. And 1, 2, 3, 4, 5 at 5, 0. Those are my points. Going to draw my line. And put arrows on it. And wait, there's one more thing. Oh yeah, it's less than. It's not included, so I need to do a little bit of erasing here to make this a proper dashed line. So I'm going to go through and just chop it up a little bit to indicate that this is not part of the solution, but is in fact simply the boundary line for this. So there we go. I've got my dashed line now. And the next thing I need to do is go and figure out which side of this am I going to put this on. I'm not sure. Again, it's digital, right? By that I mean it's either above it or below it. It's one or the other. So there's every reason in the world to pick something easy like 0, 0. And is 0 less than a negative 15? Well, the answer to that is no, it's not. So it's over here. It's on the other side. It's down below this line. Now I can test that if I'm unconvinced. So I'm going to again use 10, 0. So if I use negative 3 times 10 is a negative 30. Plus 0 is still a negative 30, and a negative 30 is indeed less than negative 15. So I've tested a point here to verify what I already knew, is that it's not above this line, it's below this line that we have our region of points. And again, I shade this in to indicate that it's my possible region of solution, and I've now graphed the inequality, negative 3x plus 5y, is less than a negative 15. Okay, one more example for you. And this, I think, is more relevant to your market day work than what I used in the last standard form problem. And this is, you have $20 to spend on your parts for market day. And you got using ribbons and balloons. Or maybe it's just your market day decorations. Ribbons cost $1.50 a roll. Balloons cost $2 per package. How many rolls of ribbons and packages of balloons can you buy? Well, this is an inequality, because what you have is you can spend up to $20. So when we write this in, I've got that $20 is going to be greater than or equal to whatever I spend. Now I'm spending money on ribbons and balloons. Well, I have an X value for those. It's a, if you will, or excuse me, I have a rate value. It's $1.50 a roll for the ribbons. So that's 1.5 times the number of ribbons that I have, plus for balloons, it's $2 per package. And so that's $2, and I'll use B for balloon packages. So how many rolls of ribbons and packages of balloons can I buy? Well, I can graph this inequality and get some sense of my answers. This is a quadrant 1 problem. By that I mean quadrant 1 is here, is the ribbons and balloons are going to be positive. I will not have negative balloons nor negative ribbons. I need to decide which one is R and which one is B. Since I wrote R first, I'm going to put that here. And I wrote B second, I'm going to put that here. So that's my number of balloons. I'm going to make a t-table to help me graph this. It's going to be R. R and B. It's like Greek letters or something. R and B. So when R is 0, B is 10, because 2 times 10 is 20. Now it's a little bit more difficult for me here to look at if B is 0, because I'm going to get some weird fractional result. So I might want to try something else. I know 150 times 2 is going to be $3, right? Well, that won't work because this is going to be some even amount. So how about times 4? So I'm going to make 4 of these. So 4 times 150 is $6, right? Yep. And then 6 from 20 leaves me with 14. So that must mean 7 is going to be my B value, right? So you get how I did that? I'm just trying to keep it simple. So let's see. So $6 plus 2 times 7 is 14. And that'll give me $20, right? So 4 times 1.5 equals 6. Okay. So I've got 2 points. I can go ahead and plot them in here. And we'll see what we get. So I got 0, 10. R is 0, B is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one of my boundary points, and that's if I only buy balloons. And now out here at 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. And that'll give me my enough to where I can draw a line. And connect it. So now I've got my line. There's no arrows on the end because it is going through here. It's actually, I've drawn the line, and I needed to have instead put in dots because it's not true that I could have a fractional number of balloons and ribbons. are packages of ribbons and rolls. I'm either going to have one or I'm not. And so I'd have to look in here for the digital or the integer solutions and say that here is a point, here's one, I should have another one in here somewhere. Okay. So I've got these values that are going to give me actual packages of things, not partial packages. And again, when I fill this in here as a solution set, I can't just mark it as a zone of solutions. I'm saying it's below the line because I can't be beyond this. That's the highest I can be. So since I've got to be below this point on B, then this is my region in here that my values are. But it's only the integer solutions. It's only where the axes cross that I have solutions. In this case where it's possible to do this, you might, it's a bit tedious. You might shade it and comment in an editorial way to say that only the digital solutions or integer solutions are valid, and spare you this tedium of marking every point. It's gotten boring already, huh? So every point along this axis is possible. You could buy one package of balloons and nothing else, right? That could be your choice. You could save some money that way. Equally true, you could just buy ribbons. So these are all solutions to your inequality. And we have our graphical values. Now, to optimize this is a whole different thing, which is to say, what are the possible values that would give you the optimal result, which would be effectively spend all your money. If you want to balance it, you're going to be in here. If you want more balloons than ribbons, it gives you a sense of where you would need to get to solve that. So we've got our equation. We have this 20 is greater than or equal to 150R plus 2B. We have our region of solution, and then it's your decision as the capitalist to decide what to do. Hey, that's it for Chapter 6. Good luck on your mastery quiz, and if you have questions, again, please ask. A lot of material that we went through in this chapter. A lot of it is connected and interrelated, and it builds on past material. I think you're going to find that preparation for the test is actually pretty straightforward. Good luck with the test. I hope you get to it soon.